to Chemistry Made Easy with Bright Edo. In today's video lesson, I'll be discussing about Graham's law of diffusion. Now, Graham's law of diffusion was propounded by a man called Thomas Graham. Now, what does the Graham's law of diffusion state? The Graham's law of diffusion states that the rate of diffusion of a gas is inversely proportional to the square root of its density, or you say the rate of diffusion of a gas is inversely proportional to the square root of its molecular weight, or you simply say molar mass. Now, mathematically, the Graham's law of diffusion can be given as rate of diffusion of a gas is inversely proportional to the square root of its density, or you say the rate of diffusion of a gas is inversely proportional to the square root of its molar mass, or you simply say molecular weight. Now, in solving problems on the Graham's law of diffusion, we are to take note of different things like arrow in this context. And what does arrow signify? Arrow talks about rate. Now, on the Graham's law of diffusion, rate has the formula which is simply rate is equal to volume over time taken. Volume over time taken. Now, the rate has an SI unit dependent on the parameters given. For example, the volume is given in cm cube and the time taken is given in seconds. What will be the SI unit for the rate? The rate SI unit becomes cm cube per seconds, or you say cm cube per seconds. But if the volume is given in dm cube, what will be the SI unit? Let's say the volume is given in dm cube and the time is given in minutes. The time is given in minutes. What will be the SI unit for the rate? The rate SI unit becomes dm cube per minutes, or you simply say dm cube per minutes. This is how to determine the SI unit of the rate dependent on the parameters given. Now, on Graham's law of diffusion, we have different formulas to understand. Now, I'll be showing us different formulas to memorize when solving the problems on the Graham's law of diffusion. Now, let's work with the first mathematical expression. We said that the rate of diffusion is inversely proportional to the square root of its density. So if the rate is increasing, it means that density will be decreasing inversely. If the rate is increasing, it means that density is reducing. Same applies to rate increasing, the molecular weight will be decreasing. Now, this is what I mean. Now, Formula 1. On solving problems on the Graham's law of diffusion, let's see. Arrow 1, which is rate 1, divided arrow 2, rate 2, Comparing it with density, we have the square root of the density, but basically density 2 over density 1, because in this contest we are comparing rate and density, and we recall we said when rate increase, density reduces. Now you can see we have arrow 1 over arrow 2 dividing the square root of d2 over d1. Now, comparing rate and molar mass. Comparing rate and molar mass, we have an equation to be arrow 1 over arrow 2 is equal to square root of molar mass 2 over molar mass 1. This is another equation we should memorize when solving problems on the Graham's law of diffusion. Now let's proceed further. Let's proceed further before we start solving practice problems that will enable us understand the concept of Thomas Graham's. Now, next formulas. Now, let's quickly move over to other formulas derivation. Now, let's check this our formula we've written already. We said that rate is equal to volume over time. So in this context, rate here is directly proportional to volume and inversely proportional to time. What does that mean? Now, let's relate rate and volume. Let's relate rate and volume. Since we've said that rate is directly proportional to volume and inversely proportional to time, what does that mean? It means that whenever the rate is increasing, volume increases. But whenever the rate increases, time decreases. So let's relate both of them. We simply have an equation to be arrow 1 over arrow 2 is equal to V1 over V2, because whenever the rate increases, volume increases. But let's relate rate and time. Rate and time. In this context, rate is increasing, time is reducing. So what will be the formula? Is simply arrow 1 over arrow 2 is equal to T2 over T1. Now we have different formulas, different derivations on the Graham's law of diffusion. Let's quickly talk about the last two formulas I'll be giving us on this contest. Now, let's relate volume, time, and density. Let's relate volume, time, and density. What will be the equation for this? If you could recall, we said that rate is inversely proportional to density, because rate increasing, density reducing. But we said that for rate and volume relationship, when rate increases, volume increases. But for rate and time relationship, when rate increases, time reduces. So what will be the equation for this? The equation is simply, let's write according to the way it's written here, which is volume, time, and density. So we have V1 C2 over V2 C1 is equal to square root of D2 over D1, because according to rate, volume increases, according to rate, time reduces, and according to rate, density is inversely proportional, which reduces. Now, let's quickly relate volume, time, and molar mass, which will be the last formula for this video lesson before we start solving different practice problems on this contest. Now, volume we already know is directly proportional, so it's basically V1 T2 over V2 T1 is equal to, same applies to the molar mass or molecular weight, which is molar mass 2 over molar mass 1. Now, basically, these are the formulas we must take note of when solving problems on the Graham's law of diffusion. Now, let's quickly go over to this question and analyze the question and solve the question, and also move over to other practice problems that will enable us understand this concept better. Now, what does this question say? The question says, given the rate of diffusion of a gas X is 200 cm³ per second. So it means that the rate is already given. Given the rate, so let's say the rate is already given. So our rate is already given to be 200 cm³ per seconds. Given that the rate of diffusion of a gas X is 200 cm³ per seconds, what volume of X, which is the gas, will take a whole day to diffuse through an orifice, which talks about through a vent, or you say through a hole. Now, let's quickly analyze this question. The rate is already given to be 200 cm³ per second, and they are asking us to determine the volume of the gas X that will take a whole day. So this whole day here talks about the time. Whole day here talks about the time. And how many hours are in a day? We have 24 hours in a day. 24 hours in a day. So basically, the time becomes 24 hours. They are asking us to get volume of gas X. If you recall earlier on, we gave relationship between volume, time, and rate. And what is the formula? We said that in solving rate problems, it's simply volume dependent on the SI unit over time. Now, if you can recall, we said that the SI unit of rate is determined according to the parameter given. Now, you can see that the SI unit now is in cm³ per seconds. So it means that our time will be in seconds, not in hours. So basically, we convert 24 hours to seconds. And how do we do that? Very simple. We simply say 24 hours times 60 times another 60. When we do this, we get 86,400 seconds. 86,400 seconds. Now, they are asking us to get the volume. Very simple. Let's quickly analyze. What we do, we make volume subject of formula. Making volume subject of formula, we simply get rate times time. Rate times time. So basically, volume becomes, what is the rate? 200 cm³ per seconds times the time, 86,400 seconds. So basically, the volume becomes 1728,000 cm³. Now, this is the volume in cm³. So basically, this is the answer to this question. Now, let's quickly move over to another practice problem that will enable us understand this concept better. Now, let's quickly move over to the second question. Now, this question says 300 cm cube of methane diffuses through a porous spot in 30 seconds. Diffuses through a porous spot in 30 seconds. How long will it take same volume of SO2 to diffuse through the same porous spot? Now you can see that the volumes are the same. So it means that the formula we are to use does not have any business to do with volume. So how do we deduce out the formula to use in this question? Now you can see that we are given the two compounds. Now these compounds brings our mind to understand the concept about molar mass. When you have a compound, it means you can determine the molar mass from that compound. So let's just do something. Let's see from our relationship that rate and molar mass, that R1 R2, which is R1 dividing R2 equals M2 over M1. These are the relationship between rate and molecular weight, or we say molar mass. And we were given time, and this time is for the methane gas. And what is the relationship between rate and time? The relationship between rate and time, it means that they are inversely proportional. So whenever rate is increasing, it means that time will decrease. T1 over T2, from our relationship that says rate is equal to volume over time. So it means that rate is inversely proportional. So we've deduced our relationship between rate and molecular weight and relationship between rate and time. So, and the parameters we have to use are these, because we are given the compounds to determine the molar mass, and also we are given time, and we are asked to look for time for another gas. Now, let's bring out the formula to use. So basically, the formula we are to use will be relationship between molar mass and time. Relationship between molar mass and time. Now, let's bring out the formula. Now, it's simply T2 over T1 equals roots of M2 over M1. Now, the question says 300 cm cube of methane. Methane is the first gas mentioned that diffuses through a porous spot in 30 seconds, which is the first time for this question. The first time, because it's for methane, which is the first gas mentioned. So basically, methane we carry the molar mass 1, and also this is for the molar mass 1 still, and also this is for the time 1. Now, and this we carry, which is the SO2 we carry, the molar mass 2. Now, we are to determine the time 2 for the SO2 gas. Now, let's quickly determine their individual molar masses. Let's quickly determine their individual molar masses. Now, what is the molar mass of methane? Methane is simply CH4, and SO2 is this. What is the atomic mass of carbon? 12 plus 4, which gives us 16. And SO2, sulfur 32, oxygen 16 times 2, giving us 64 grams per mole. And this applies 64 grams per mole. Now, basically, the time 2 is what we are asked to determine. So we'll make it X dividing time 1, which is 30 seconds, is equal to the square root of the molar masses. The second gas is SO2. So basically, the molar mass of molecular weight is 64, dividing M1 for methane, which is 16. So now, Root of 64/16, it gives us 2. So we have x over 30 equals 2/1. So when we cross multiply, x becomes 30 times 2/1. So basically we have 60 seconds for the time 2. Okay, 60 seconds for the SO2 gas. So basically, this is how to solve problems on the Graham's law of diffusion. And don't forget to subscribe to this channel for more videos. Anticipate more interesting videos on chemistry. Thanks for watching.